Hello everyone, this is Dr. Sibi Jose, Associate Professor of Engineering Chemistry, Technocrats Group of Institution Bhopal, welcomes you all in this video lecture series. Today we are going to discuss about the lubricants and lubrication. Students, it is the portion of Engineering Chemistry, Chapter 2. The question arises, what is lubricant and what is the function of lubricant and what is the importance of lubricant in machinery parts? Students, in all type of machines, basically moving, sliding and rolling functions are going on whenever the two parts of machines are comes in contact or rub against each other. This mutual rubbing of machinery parts can make a friction in between the machinery parts due to the lock of or scissoring of the machinery peaks or small peaks or parts. And this type of frictional forces may oppose the relative motion, and the wearing occurred or wearing result in between the machinery parts whenever we try to reduce the frictional force or whenever the frictional force can be minimized with the help of applied forces. So this drawbacks of frictional force can be minimized or can be removed with the help of certain type of chemical substance or chemical reagent which is known as lubricant. So, lubricant is a type of substance or chemical compound which is applied or introduced in between the machinery parts for controlling the friction or to prevent the wearing, tearing and surface deformation formed during the functions of machinery parts. Or in another way, we can say that a substance used to prevent a contact of machinery parts or to control the relative motion, thereby reduce friction and wearing, and the substance that also introduced for controlling the friction. Now, we are going to discuss what is friction. As I say that lubricant is an important substance to control the friction in between the machinery parts. So whenever a surface of machine moves over the another surface, resistance to relative motion of the surfaces arises. When we look at the solid surface, it's appear smooth to naked eyes, but this smooth surface shows irregularity of projections and cavities when viewed under high power microscope. So in a short way, the friction may be defined as the opposing force that is set up between the surface of contact when one body moves over the surface of another body. As you seen in this diagram, material 1 upper layer and material 2 lower layer, in the gaps between two parts of machine is very small or a thinny layer is present is here. So a lubricant should be able to control the friction of small peaks or locking of small piece by introducing adsorption over the surface of machinery parts or by forming a oiliness surface over the surface of machine. Here a general diagram of friction is giving here when as you seen that a gap between two surfaces is very small. Actually the machine working at various temperature and speed under the presence of higher temperature and pressure. Some kind of machines are low working machines or light machines, and some kind of machines are heavy weighted machine. Basically light weighted machines are working at low speed, low temperature and low pressure, where the load in between the machinery part is very small, while in case of heavy weighted machine, the machine exerts higher temperature, slow speed, higher temperature, higher pressure and heavy load. In that case, the kind of lubricants that we need there to control the friction is high viscous type of lubricants there we need, and high viscous lubricants are able to control the corrosion also that generally formed in the presence of water. Okay students, here now we are going to discuss about what is the Effect of friction. As you mentioned here, the frictional force opposes the relative motion between the moving parts of a machine. Therefore, extra energy has to be spent to overcome the friction, which increases expenses of energy. The friction between the moving parts of machines also produces heat, which causes damage to the machinery. Thus, friction causes wear and tear of the moving parts of machinery in contact, and due to this cause, the machine loses their efficiency and becomes useless. So, friction is a very harmful situation or very critical condition under the temperature and pressure whenever the machine exerts lots of load and lots of pressure over the machinery parts. Here now we discuss about the basic functions of lubricants. Students, as you know that lubricants is an important or necessary substance for the machine. So there are 7 important functions of lubricants are mentioned here, that is importantly described for the machinery parts. The first and the foremost function of lubricant is to control friction over the machinery parts or in between the moving, sliding and rolling parts of machine. Thereby it minimizes the production of heat, thereby it's control the production of corrosion and rusting. The second important function of lubricant is to reduce the wearing and tearing of machinery parts, to keeping the moving parts of machine apart. Okay, so wearing and tearing are the general cause that basically occurred or produced due to the presence of locking of small peaks and small parts of machine. The third important function of lubricant is lubricant reduce the maintenance and running cost of machine, because lubricant is worked or act as a coolant for controlling the emission of the extra heat or to control the absorption of extra heat, and it also work out to reduce the production of heavy heat in between the moving parts of machine that are coming in contact during the working stage. Okay. The fixed function of lubricant is to increase the efficiency of the machine by reducing the loss of energy, and the lubricants act as a coolant also, as well as it is also it is also worked for keep out the dirt from the machinery parts, and it also act as a seal or wax. Okay, and it's try to control the emission of harmful gases from the small pores of the machine, or it's control the emission of excessive gases or harmful gases to the environment. Okay, and lastly but last but least, the lubricants is also important for controlling the corrosion, or we can say that lubricants act as a corrosion preventer, and by functioning all the 7 type of or 7 to 8 type of functions of lubricants, the lubricants are most effective for controlling or to improving the efficiency of the machine, controlling the corrosion and efficiency of the machine. Now, here a diagram is given where the action of lubricant is mentioned, where the lubricant act as a seal in between the piston part. Lubricant used between piston and wall of the container cylinder prevents the leakage of hot gases produced by the internal combustion. That means it acts as a seal. As I mentioned here, a very important function of lubricant is act as a seal or wax to control the emission of hot gases or harmful gases to the environment. So this is the best diagram or the presentation of showing the effect. Now we move to the classification part of the lubricants. Students, as you know that lubricants is a very important chemical series compound or substance. It is basically in generally it is divided in 3 subcategories: liquid lubricants, semi-solid lubricants and solid lubricants. These 3 categories are based on their physical states, but a part of these 3 classification of lubricants, some kind of modified or refined lubricants are also available in nowadays, like synthetic lubricants and biodegradable lubricants. The important examples of liquid lubricants are oil. Basically oil, and oil is categorized in 3 categories: animal oil, vegetable oils and mineral oil. And examples of vegetable oils are sunflower oil, olive oil, and animal oils, lard oil, sperm oil, and the mineral oil are fuel oils. Okay, petroleum product oil, etc. Basically, the basic property of liquid lubricants are very containing low viscous nature, liquid in nature. That's why the evaporation of oil is more fast as compared to the semi-solid and solid lubricants. So due to the low viscous nature of oil, the oil is mostly applicable for the light weighted machine, because there be in the heavy weighted machines, or those type of machine which working in the high pressure and high temperature, the liquid lubricants are failed to lubricate, to make a particular layer, or to make a protective coat over the surface of machinery parts. The second category of lubricant is semi-solid kind of lubricants. For making a semi-solid kind of lubricants, here the liquid lubricants are mixed with some kind of viscous solids. Semi-solid lubricants contain two kinds of examples: graphite and semi-solid like grease and wax type of materials. And third category is solid lubricants. Solid lubricants are best lubricants, categorized as a best lubricants as compared to the liquid lubricants and semi-solid, because it contains heavy viscous nature, and the flash and fire point of solid lubricants are more high as compared to the liquid and semi-solid lubricants. The example of solid lubricants are graphite and molybdenum disulfide. Now, here we mention some kind of specific properties of liquid lubricants, because liquid lubricants are simply available. Their refinery methods are simple, and their uses and commercial based applications are available in a large excess. That's why the liquid lubricants are mostly famous in between the all around us. That's why the specific properties of lubricants are mentioned or explained with the help of liquid lubricants. The first important property of liquid lubricant is viscosity. Students, as you know that viscosity is a measure of a fluid, or it is a measure of oil which determines its resistance to flow. That means viscosity is inversely proportional to flowability, and viscosity resists the flowability of the liquid. Viscosity of the lubricant oil determines its performance under operating condition. A low viscosity oil is thin and flows easily, and high viscosity oil is thick and flows slowly. And for working at the high temperature and pressure, or in the presence of heavy load, the machines need high viscous oil. But whenever we works with the light weighted machine which is working at low temperature, low pressure, and slow speed, there we need the low viscosity oil that is thin and flows easily. Now, the mathematical expression of viscosity is expressed through the help of viscosity index. Viscosity index is the mathematical expression of viscosity, and it is basically defined as the rate at which the viscosity of a lubricant changes with respect to the temperature is measured by a scale known as viscosity index, and it is mathematically expressed by the formula L minus U upon L minus H multiplied by 100, where the terms L and U, here the viscosity of high viscous oil. High viscous oil, that means that type of oil which contains the viscosity more than 100, and the low viscous oil that contains the viscosity less than 0. Okay, so VI, viscosity index of Pennsylvanian oil, is more than 100, and the viscosity of naphthalene based oil, Gulf oil, is contains 0. That means the Gulf oil is taken as a reference for the low viscous oil, and the Pennsylvanian oil is taken as an example of high viscous oil. Okay, and the viscosity index is unitless property, while the unit of viscosity is either poise or centimeter per second. Next property of oil is emulsion number. What is emulsification? Emulsification is the property of water to get mixed with the emulsification is the property of water to get mixed with the oil or some kind of soluble liquids. Basically, emulsification number or steam emulsion number is an important property. With the help of it, you can easily check the number of rate of absorption of moisture of oil, because if the oil contains some kind of moisture, so corrosion or rustings are postly produced over the surface of machine whenever the machine comes in contact with the heat or some kind of moisture. The rate at which the quicker the oil separate out from the emulsion of water, that means better is the lubricating oil. Or in another way, you can say that for a good lubricating oil should contain lower emulsification number. Now we move to the next property of an oil, a lubricating oil, that is flash and fire point. Students, flash and fire point is an important property to explain the volatility or fire burning property of lubricating oil. Basically, the definition of flash point is very simple. The temperature at which, the minimum temperature at which the oil gives off sufficient oil vapors that ignites for a moment when a small flame is brought near to it, and the fire point is the minimum temperature at which the lubricant's vapors burns continuously at least for 5 seconds whenever a small flame is brought near to it. And a good oil should contain a fire point more than flash point, above the flash point of 10 to 20 degree. So a good lubricating oil must contain higher flash and fire point. Now we move to the next property, that is cloud point and pour point. It is also another important property, that is the parameter by which we can easily check the quality of oil suitable for the machinery parts. Cloud point is the minimum temperature at which the paraffin wax present in the oil start to solidify under the cool temperature or under the freezing temperature, and a hazy look is occurred during the solidification process. And the pour point is the minimum temperature at which the lubricant just ceases to flow or starts to flow whenever the temperature is raised or up to the room temperature. Both indicate suitability of lubricant in cold condition and thus must be low. So for a good lubricating oil, the cloud and pour point must be low, because if the oil contains high cloud point and high pour point, that means that type of oil can make jamming of the machine in cold season, or that type of, or in between the machinery parts of that machine, slow speeds machine, where the jamming occurred in the presence of winter seasons. Okay. Lubricating oils used in capillary feed system should have low cloud point, otherwise impurities will clog the capillary, and a high pour point leads to the solidification of lubricant that may cause jamming of the machine. The next property of the oil is neutralization point. Neutralization means acidity or alkalinity of oil. Neutralization point determines acidity or alkalinity of oil, and it is measured with the help of milligrams of potassium hydroxide KOH, and in the presence of KOH you can check the alkalinity or base value and acidity or neutralization value of the oil. And this property of oil is helpful to check the expiry date of the oil. That means if the neutralization point occurs before the time, that means some kind of alkali metals are contaminated in the oil, that gives some kind of volatility to the oil, as well as the oil makes unsuitable for the machinery parts. And next property is saponification number. It is the milligrams of KOH required to saponify 1 gram of oil. Saponification is hydrolysis of an ester with KOH to give alcohol and sodium potassium salt of acid. Saponification value helps us to ascertain whether the oil under reference is mineral or vegetable or a compounded oil. That means contamination of an oil is checked by this specific property, because each oil has its specific saponification number and deviation from it indicates the extent of adulteration of oil. Now we move to the mechanism part of the lubricant, that is known as lubrication. Lubrication is the mechanism by cause of which we can easily check the resistance against the friction, and it is followed by 4 methods: hydrodynamic lubrication method, hydrostatic lubrication method, boundary lubrication method, or extreme pressure lubrication. Out of 4, the 3 mechanisms are most important. First one is hydrodynamic lubrication. It is also known as thick layer lubrication and fluid film mechanism. While the boundary lubrication or thin layer lubrication is secondary. Extreme pressure lubrication is generally occurred at the condition of high pressure and temperature, and where the machine exert higher speed, high temperature and high pressure. If we talk about the hydrodynamic lubrication or thick film mechanism, in this mechanism, the machinery parts absorb a bulk quantity of oils in between them. Basically, during the thick film lubrication, in between the machinery part, at least the angstrom size of 1000 angstrom lubricating oily layer or bulk layer is required to control the friction over the surface. Hydrodynamic lubrication is said to exist when the moving surfaces are separated by the pressure of a continuous unbroken film or layer of lubrication. In this type of lubrication, the load is taken completely by the oil film. The basis of hydrodynamic lubrication is the formation of an oil wedge. When the general rotates, it creates an oil taper or wedge between the two surfaces, and the pressure buildup with the oil film support the load. Students, in the hydrodynamic lubrication or thick film mechanism, the bulk quantity of lubricating oil is required to make proper adsorption layer in between the parts of machine, and this type of mechanism is applicable for the slow speed, high speed, low temperature and low pressure. Again I repeat, this type of mechanism is required for high speed, low temperature and low pressure. The second important mechanism is boundary lubrication or thin film mechanism. Here, this type of mechanism is followed by semi-solid or solid lubricants. The boundary lubrication exists when the operating conditions are such that it is not possible to establish a full fluid condition, particularly at low relative speeds between the moving or sliding surfaces. Okay, the oil film thickness may be reduced to such a degree that metals to metal contacts occur between the moving parts reduced. The oil film thickness is so small that oiliness becomes prominent for boundary lubrication, and boundary lubrication happens when a shaft starts moving from rest. The speed is very low, the load is very high, and the viscosity of the lubricant is too small. Here a diagram is given to explain the thin layer mechanism. A thin lubricant should have high viscosity index, good resistance to heat and oxidation, and good oiliness and low pore point. Basically, the liquid lubricant is not so much important for conducting the boundary mechanism or thin layer mechanism in between the machinery parts. Here, strictly we can follow this mechanism for the semi-solid and solid lubricants, because that both category of lubricants may contain high viscosity, high flash and fire point, and better lubrication property as compared to the liquid lubricants. That's why the thin layer mechanism is specifically defined for solid and semi-solid lubricants. Next, third mechanism is extreme pressure lubrication. The term is clearly indicates that the surface area where the high speed, high temperature and high pressure is occurred, on that condition on that critical condition, simple lubricant is failed to make some kind of lubrication over the surface area, and so to maintain the extreme pressure in between the machinery parts, the simple liquid lubricants or the solid and semi-solid lubricants are mixed with some kind of additives or external salts, whenever the additives is mixed with the solid, semi-solid or liquid lubricants, the kind of lubricants are known as extreme pressure lubricants, and this type of lubricant is more applicable for the high pressure areas. And the examples of extreme pressure lubricants are chlorinated ester and sulfurized oil. Okay, as I told you that basically the lubricants are classified into 5 categories. So synthetic and biodegradable lubricants are also important in this series. So synthetic lubricants are such kind of lubricants that is applicable or that we can use for conducting the extreme pressure lubrication. The examples of synthetic lubricants are LAB, linear alkyl benzene, and alpha olefin, PAO, polyalpha olefin. Biodegradable lubricants are also important for conducting the extreme pressure lubrication, and the biolubricants are basically extracted from the plant esters, plant-based esters, for example from the soya bean or soya plants. Okay, extreme pressure lubrications are most important lubrication technique as compared to the boundary layer or hydrodynamic technique, and by this techniques the lubricants showing some kind of extra applicable properties over the surface of areas, and the extreme pressure additives are the organic compounds which possessing the active radicals or groups such as chlorine, sulfur, phosphorus, etc., and these compounds react with metallic surfaces at high temperature to form the metallic chlorides, and this kind of mechanism can make extreme pressure lubrication more adorable or more acceptable for the machinery parts. Okay. And this diagram is basically show for the hydrodynamic lubrication. Hydrodynamic lubrication where we need a bulk quantity of lubricant layer in between the machinery part to maintain the high resistance against the frictional force or to control the high applied force, because if the friction is dominating in between the machinery parts, the relative motion is lower, and to minimize the friction resistance or to break the friction resistance, the applied forces could be strongly forced out over the surface area, and this can make the surface area more weaker and easily the wearing, tearing and surface deformations are occurred during the breaking of frictional resistance. Okay, so lubricants in shortly in the last slide, here we concluded that lubricant is an important substance that we are needed to improve the efficiency of the machine or to control the wearing, tearing and surface deformation occurred in between the small peaks and small areas of machinery parts. Okay, that's all about my side. Thank you so much students. Have a nice day. We will meet in our next video lecture. Thank you so much.